Okay, so now we said that your curve is not symmetric. Remember, your curves are skewed to the right. They're skewed to the positive side. They also go from 0 to infinity. There's no negatives. There's no plus or minus any scores. They're both different. They're both positive. Now, the easiest way to do this without memorizing a formula is the same way we do your inverse norm. We start off like this. We divide it by 2. Once you get this part, subtract it from 1. You get the other part. You could also tell on your table, remember they're symmetric about the middle. The 90 and the 10 are in the middle. So when you kind of make a little rainbow across the top, 0.995 and 0.005 are add up to 1. Just take those values and write them down. Don't worry about who's left, who's right. The smaller one is going to be on the left side because it goes from 0 to infinity. The larger one is going to be on the right side. So as soon as you write them down and place them on your chart, you should see them. Remember to look up your degrees of freedom, not your n. Okay? Same thing here. Subtract from 1, divide it in half, and subtract this guy from 1, or just look at your chart and make yourself a little rainbow across the top and find your pieces. Yes?
The lower one's always X squared L, right?
Well, the lower one is always the left, but instead of worrying about at this point which one is it, the lesser one has to go here on the left, the smaller one, because this goes from 0 to infinity. So it's actually like a backwards approach, because what happens is your chi-square is area to the right. So it's always area to the right of me. So my larger one is the area to the right. It's going to be on the left side. The 0.99. Yeah. So the 0.99 to the left is going to give me the smaller number on the left-hand side. But instead of worrying about that, just write them both down. The left one has to be smaller than the right. Everybody okay with these? Did everybody find these? Yes? Anybody not find them? That's the hardest part of this whole thing. It's finding those two pieces. And then that's it. So from here, we can go make your confidence interval. Oops, wrong one. I gave you your class notes so that it'll help you. Oops, wrong one. There. Some odd reason, this is not working. I have no idea what this is. Yes.
What are we doing on Thursday next week?
Probably taking a test.
Oh,
what?
3.
Yes.
What's that stone they drive?
Probably taking a test to wrap like this. It's either going to be Wednesday or Thursday.
Do it Wednesday, Thursday.
Or we could not do anything next week. I could give you homework over the break. So you can review. Better idea, right? Alrighty. Okay, now we did all this, so we are up to this. Remember, yeah, I said this is going to look worse than it is. Okay.
Every single time someone said that,
It looks far worse than it is. You did the hardest part. It looks very bad. First of all, I gave you the formula. Second of all, there's no calculated step. But let's take this apart. What is n minus 1?
N minus 1.
Degrees of freedom. So you know that. Isn't this the ones you just found?
Yes.
Yes.
Square root squared?
And what is S? Sample standard deviation. So I want you to write this on your paper. This is the biggest difference. This squared is the sample variance. Yes. S by itself is a sample standard deviation. So the first thing we're going to do is find your two critical values, your x2r, your x2l, which we know how to find. That already tells us our degrees of freedom. Notice they don't have any mean in here. We build a confidence interval without the plus or minus e anymore. There's no margin of error in this. This does not work like the other ones. It's opposite. Every area is to the right. It's a skewed curve. It is not a normal curve. So all we have to do is either find the standard deviation or the variance. Now here's the difference. If they give us the variance, listen carefully guys, that's s squared. I just put the variance there. If they give us the sample standard deviation, then I have to put my sample standard deviation here and square it. So the only difference is going to be which one are they giving me. Okay? Because it needs to be s squared to get to a variance. And don't you take your sample standard deviation and square it to get to your variance? So if they just give us a sample standard deviation, we're going to square it because we are looking for a variance. There's no plus or minus e in this. We go right to the interval. This is it. So let's try one. It looks far worse than it actually is. We're going to do the same exact thing as before. We're going to verify that it's a normal distribution. They're going to just tell us what we should do here. We're going to find our degrees of freedoms. We could also use an S if they give us an S or an S squared, whichever one we have to use. We find our x2, our x2l. We make our thing. Once you take the square root, that's your interval for standard deviation. So you've got variance, standard deviation. So let's try one. So if you kindly look at page 333, we are gonna do a confidence interval. You're gonna randomly select and rank 30 samples. So we're gonna pull this information out. 30 samples, assuming that the weights are normally distributed with the sample standard deviation, that's just a plain S. We're going to construct a 99% confidence interval for the population variance and the population standard deviation. Yeah.
Do you have to write any of the these right? DF equals 29. Do you need any?
No, you can write DF equals 29. You can write that code, go right to the chase. Yeah.
What?
DF, degrees of freedom.
Oh, yeah.
Now, first thing we're going to do is do the 1 minus 0.99 divided by 2. It's going to give us 0.01, and we're going to divide 0.01 in half. So what do we?
We're gonna get
0.005.
And what's the other one? 995. Okay.
Subtract it
From 1. Or just follow your table with the symmetry. Like in your table, it goes across like a rainbow. Now, pull me out those two numbers. And we'll decide which one is your x2l and which one is your x2r. 31.09, is that the larger of the two?
No, the smaller one is 31.319.
Wait, hold on.
You sure?
0.005?
No.
No. Degrees of freedom 29?
Oh,
It's 52.336.
It's what? 52.336. And what's the smaller one?
13.121.
Okay, thank you.
Yeah, do we have to draw for
No, I just draw it so that we know which one is the left, which one is the right. Because how do you know which one is the left, which one is the right, unless you follow their other formulas, and I don't use that, I just use this. Now, here's your formula. This is how easy this formula is. And it's a little bit confusing with the R and the L here, so just hang in there for just 1 second. Okay, let's put them in. Degrees of freedom is your n minus 1. So what was our degrees of freedom?
79.
Now, here's the catch. The S squared is a variance. They gave us a sample standard deviation. So in this case, we're going to do 1.2 squared. We need a variance. We take the sample standard deviation, we square it. We're doing an interval for a variance, so we need this to be a variance. I'm going to do the numerator of this guy first. Isn't it the same exact thing?
Yes.
Same exact thing. Now, here's the problem with my denominator. One would think that the one on the left would belong on the left. However, you're setting up an inequality. So if you divide by the smaller number, if I divide this, 6 divided by 2, 6 divided by 3, this is going to give me a 3, this is going to give me a 2. Is that going to make my inequality work? No. So what I want to do is divide the bigger number on the left-hand side and the smaller number on the right-hand side. That's why those two are switched around. And if you didn't see it, as soon as you do your calculations, you'll say, oh, I just got to switch my inequality around. I've got the lesser one on the wrong side. So we're going to put the larger one over here. The one on the right is going to go over here, the larger one. That's why if you do this first and you find these pieces first, they'll slide right into your formula. So now all you have to do, and it works perfect in your calculator, you say 29, just like this, squared, divide by, you hit enter. You don't need any extra parentheses. It'll go right through. Now, rule of thumb, I usually go like 2 or 3 decimals. They usually go about 2 decimals. They usually go to whatever your standard deviation is, which is only 1. So at least go 2 or 3. 2 or 3.
So this is the same thing, you just take the sample and square it at the top, basically.
And you just have to place your x2r, your x2l in the right place. However, if they're switched around, as soon as you resolve all these, you'll realize they're in the wrong order and you'll change them. So that's why I'm saying this looks far worse than it actually is. There's not a lot to this. So this is going to become 0.80. And then this is your variance interval.
Would it be 3 this one, please?
2, you can go 2. You can go 2. Now, to get your standard deviation one, don't I take the square root of the variance to get a standard deviation? So I take the square root of all the pieces.
I didn't get that money.
Try it again.
No.
So this should come out to 0.89. Okay. What this tells me is I want to be 99% confident that my population variance for these samples of allergy medicines will fall between 0.80 and 3.18. I want to be 99% confident that my population standard deviation for the allergy medicines fall between 0.89 and 1.78. Now remember, if you're weighing these samples of medicines, you want to be pretty close, don't you? You don't want them to be milligrams or pounds away or anything. You want them to be very close. Your variance is very small. So when we're measuring small things, we usually look at a variance. Boys, we usually look at a variance to measure small things, especially in the medical field or the manufacturing field. That's another one. So does this make sense to you? There's no calculator step for this. I will give you the formulas. And you really, the only one you're going to have to think about is this one. But what you need to think about is, if you're doing a variance interval, you need to make sure that that result comes out to be the variance. So if they just give us a standard deviation, we square it. If they give us a variance, we don't square it. It's already squared.
So we gotta find the X2R, X2L first, and then.
Yes. Yes. Once you find your variance, if you take the square root of your variance, you get a standard deviation. So therefore, you have to take the square roots of everything, and this is the interval for your standard deviation for your calculation. That's all there is. There's no margin of error. There's no mean. There's no plus or minus. This is it.
The final answer is the square rooted ones.
This one and this one. Well, it's both. One for the variance, one for the standard deviation.
Oh, you have two answers.
Because one's for my variance interval, one's for my standard deviation.
Then one has to stay in square root form?
Yep. Okay. Now I want you to try it yourself too. However, I want these 3 rows over here to my left, these 3 rows over here, to do a 90% confidence interval. And I want these 3 rows to do a 95% confidence interval.
Wait,
Try it yourself too at the bottom of 333. Okay, so guys, just like to wrap this up, does everybody see the difference in the intervals?
yeah.
The 90 versus the 95 versus the 99?
Yeah, we got it.
Got it. Can you remember this from Monday?
Yeah.
Hopefully.